All right, so pleasant evening to everyone or afternoon. Taking you away from your Sunday. It's not something that I want to do, but circumstances beyond our control why we have to do what we have to do. So without further ado, we're going to dive right into today's session, okay? And as promised, today is going to be a teaching day. It is going to be a teaching day, right? However, because there are, please remember, guys, to control your microphones. Simonia, I think your mic is unmuted. All right, so I muted you. All right, good. So, as promised, guys, we are going to be going through the test paper that you would have you were supposed to get prior to um the tropical the storm that occurred on our island. So we're going to go through those questions because at the end of the day, this particular paper will kind of cover more than one thing, as opposed to coming and teaching you a particular topic today. It's going to be able to, one, I think it's going to help us to recall concepts that were taught. Two, concepts that should have been taught will also be explained as well. And there's a lot of stuff that's going to come from this paper, right? I actually have two papers. So I'm not sure if we'll be able to go through both of them, but I'm going to try. I remember that before all this happened, we were only doing two topics. We were doing fundamentals and measurement, right? So that's what we were doing. So those are the questions we're going to focus on, the fundamental part and the measurement. So hopefully I'll be able to go through the two papers with you. All right. So let's get right into it. Okay. As per usual, my new students, welcome. And I hope you enjoy the session. Remember, and you can access all the recordings on my YouTube page. Okay. So let's dive into it. All right. Board. Okay, here we go. I hope everybody's doing good though, right? I really do hope everybody's doing good. With the school assessment. Might be this. Let me see this one. All right, I think this is the paper, but it doesn't matter really. All right, here we go. So this was supposed to be your assessment paper, guys. All right. So you can see on this. Everybody's seen the screen. Everybody's good to go.
Yes, sir.
Everybody's seen the screen. All right, lovely. All right, so you can see on the screen there is a bunch of different stuff going on. All right, and we are going to be touching base on each of these. Some of them you're going to be seeing them for the first time. Some of them you would have seen them already. All right, so we're not going to take any more time or waste any more time. Let's get right into it. Okay. All right, so as you can see, the test paper was designed with the intention of giving you a 45% pass mark. That is just to set a foundation to see where you guys are at. And you're supposed to answer the questions that are related to your section, which means that if you're doing measurement, that's the topic that you should have been doing, right?
Sir,
Yes, go ahead.
is it possible for you to zoom in somewhere, please?
It's going to be a bit challenging because then I would zoom up my writing pad. Can you zoom up your screen?
Already did that.
Okay. That's the best I can do for now. Hold on, give me a sec. Is that better?
Yes, sir.
All right, good. All right, so I know it's been a while that we haven't taught, so please ensure that you stop me if I'm going a bit too fast. And if you need me to explain a concept over, please feel free. The microphone and the platform is open for you to voice your concern or your inquiries, okay? All right, good. So our first question traditionally on any exam paper is going to be a fraction problem. Give me a sec, I think it's freezing here. All right, so here we go. So we have 5/9. Give me a sec. All right, so what we have here is 5 over 9 plus 1 over 6 multiplied by 8 over 11 divided by 1 and 5 over 6. All right. Now, when it comes to any form of arithmetic meaning anything that you have to add, subtract, multiply, or divide, whether it be decimal, fractions, and or whole numbers, you must recall this rule here, this rule that we spoke about in the very first or the second week that I met you, PEMDAS. All right. And we can recall that PEMDAS implies the meaning of each letter in the word PEMDAS stands for an operand in math. So the P stands for parentheses, the E stands for exponent, the M and the D, the A and the S stands for multiplication, division, addition, and or subtraction. All right, so each letter stands for a particular operation in math. Now, when you look at this problem, you have to take into consideration PEMDAS, because the rules for division differs from the rule for multiplication, which also differs from the rules for addition. Now, if you can recall, right, if we can recall that when we're adding and subtracting for two fractions, we need to find what is known as the LCM. When we are multiplying, we have to cancel, right? We have to find a factor that can reduce the numerator and the denominator. And if you can also recall division, we can recall that when we're dividing, we have to use something known as the KCF method. That's to keep the first, change the sign, flip the last. All right. So with a question like this, then we have to look very carefully at which part of the problem should be done first. Do I just go ahead and find the LCM like that? Do I cancel? Do I keep, change, flip? What exactly do I do first? Well, according to PEMDAS, right, as you can see, there aren't any parentheses, right? There's no brackets in the question, and there is no exponent in the question either. There's no exponent. So the first operation would have had to be the multiplication part of the problem. So that means I would have to work out this part of the problem first. Right? I would have to work out this part of the problem first. So then I'm going to go ahead and I'm going to write down the 5 over 9. I'm going to leave that part alone. Then I'm going to go ahead and cancel. I'm going to reduce the fraction. Now, if you look carefully, that 8 and 6 has a common factor. And so we're looking for a number that can reduce the 6 and the 8. And as you can see here, it would have obviously been 2. So if we say 2 into 6 goes 2 times, goes 3 times. And 2 into 8 goes 4 times. So we use the number 2 to cancel the 6 and the 8. You would then realize that we end up with a simplified version for the problem, which is going to be 1 times 4 is 4. And 3 times 11 is 33. All right, so that 4 over 33 is the answer for the middle part of the problem. We're going to proceed to say divided by 1 and 5 over 6. Now, 1 and 5 over 6 is a mixed fraction. So if you remember anything about mixed fraction, you remember we stated that we use the denominator to multiply the number at the side, that is the 1, and then we're going to add the numerator to it. So that's going to be plus 5. So that's 6 times 1 is 6 plus 5 is 11 over 6. All right. So we have simplified the middle portion of the problem. Then we have converted the division part of the problem to an improper fraction. So this is what we have left. The multiplication is gone. Now we can cross off the M here. Then we can see that what comes next is the D. So we're going to divide this part of the problem next. Okay. So we're going to have 5 over 9 plus, and we're going to use the keep, change, flip. So what do we mean by keep, change, flip? The rule for division of fractions states that we should keep the first fraction as it is. We're going to change the sign from division to multiplication. And we're going to invert, change, or flip the last fraction. So 11 over 6 becomes 6 over 11. All right? From here, we're going to do the same thing we did when we just started the problem, which is obviously to work out the multiplication part of the problem next. So again, the 5 over 9 comes back down, plus. And then now, again, just like we did when we were multiplying at first, we're looking for something to reduce the fraction. So we're going to end up here then with, if we look at the 4 and the 11, one is a prime number and one is an even number, so nothing is common there. But with the 6 and the 33, you can see clearly that 3 goes into 6 2 times, and 3 goes into 11 sorry, 3 goes into 33 11 times. All right. Remember, cancellation can only be done numerator with denominator. It cannot be cancelled denominator, denominator. So again, you can't say 11 cross out 11. They're both at the bottom, so they can't interfere with each other. Okay. So there's nothing much to do here. 3 into 6 goes 2 times 3 into 33 goes 11. So our final answer for that part of the problem is going to be 4 times 2 is 8. The 4 times 2 is this 4 and this 2 right here, 8. And 11 times 11 is 121. Okay? So now the last part then, where we have this fraction, which is quite unusual. Usually we don't end up with such large numbers. But I guess the error was made when I was writing the question. All right. Nevertheless, math is math and it can be worked out. So with addition of fractions, we are going to go ahead then and we can find the LCM. All right. The LCM here can easily be calculated by multiplying these two numbers at the bottom. I believe you're going to get something like 1089. Can somebody confirm that, please, for me? Can somebody quickly confirm if it's 1089?
Yes, sir. It's 1,000.
Thank you very much. 1089. Thank you so much. So that's how you find the LCM, guys. 1018. 9 times 121, 1089. All right. Now, according to this, then we're gonna go ahead and try to figure out how many times the denominator goes into 1089. Now, 9 will go into how many groups of 9 can we extrapolate from 1089? We're going to get 121 times. We're going to put times 121 here. So that's going to be times 121 right here. And then 121 will go into 1089 9 times. We're going to put that 9 right beside the 8 right here. So sorry for the chopped up writing, guys. Okay. Now, 5 times 121, that sounds like 605. Please correct me if I'm wrong at any point. And 9 times 8 is going to give us 72. So if we add those, we should end up with a final answer of 677 all over 1089. And that would be our final answer. 677 divided by 1089. So that is how you would resolve a fraction problem like this. For those who are new and were not able to get the full breakdown lesson of fractions, you can always scroll. These videos, these lessons were posted. The title is there. So if you scroll down just a little bit on my page, you will find. In fact, let me just jump over there quite quickly for you. So if you go on my YouTube page here, you'll be able, right here, you can scroll down. Let me see here, view my channel. So you can find a lot of videos down here. So if you click on the video section and you scroll down, you'll see a bunch of different titles. So you just have to look for the one that says fraction. This is the one. See, the one that says 174 views. Oh, that's an exam paper. So the title is here, Fundamentals of Math Operations with Proper and Improper Mixed Fractions. So the title is there. It's the one with the 83 views. This one right here. This one right here. So you can always check out that if you want to get a breakdown version of this. Okay. All right. So that takes care of that particular question. All right. Good. Any questions from anybody for that question? Any inquiries? Everybody good?
Yes, sir.
Okay. Oh, you have a question or no?
No, sir.
Okay, perfect. Wonderful. All right, let's move on to the next question then. All right. So we just have spark the plug in, guys. We're just sparking the plug. So this is our first lesson, first real teaching since you know what happened. All right. Let's move into it. So the next question is another fraction question, right? Now, typically, guys, on an exam, you don't usually get 2 fraction problems in one paper, right? But I had to make up some questions to get you guys good amount of marks. So I threw another fraction question on the paper here. Give me a sec here. Nice. All right, so this fraction problem will bring out another aspect of your fractional skills that you're supposed to know. If you look carefully at it here, all right, guys, did you? Okay. Are you guys able to see my screen in 3, 2, 1? Are you guys able to see my screen?
Yes, sir.
Okay. All right. So I hope I didn't lose because I'm not sure. I thought I lost you. Did I lose you? Did you get up to the last part of the fractions that we were working out?
Yes, sir.
Okay, good. Please let me know if my screen has stopped sharing at any point. All right, so here we're at this fraction then. All right, so this one right here, we have 1 and 1 over 5 raised to the. Let's write that
Excuse
over
me, sir. You
1.
can go back to the first one. Let me get a screenshot, please.
Oh,
Because I got kicked
I
out.
actually erased this. I actually erased it.
Oh,
I
okay.
can't undo because I exited the screen.
Oh.
So you have to just write it me, okay? Right.
Okay.
So
I'm
1 and
using
1 and a.
data, so I'm getting kicked off.
Oh, that happens. Whenever you're using data, that will happen. So 1 and 1.5 raised to the power of 2 minus 5 and 3 over 5 divided by 1 and 5 over 9. All right, so here what we're looking at again is the application of PEMDAS. We can't forget this rule, guys. PEMDAS. Sir, how do I know when to use PEMDAS? You see, as long as you are required to do more than one operations at the same time in one problem, then PEMDAS will take control. All right. So in this question here, there is a parenthesis, as you can see here. There is a parenthesis. There is one right here. So they're telling you that you need to work out what is in that parenthesis. Now, before we actually talk about working out some stuff, let's do some conversions because there's a bunch of mixed fractions here. All right. And so we can't operate with the mixed fractions like that. So the best thing to do here is to do some conversions, right? So let's go ahead and say 2 times 1 is 2, plus 1 is going to be 3 over 2 squared, minus 5 is 25, so that's 5 times 5 is 25. 25 plus 3, that's going to give us 28 over 5 divided by.
Excuse me, sir. Is it 1 and 1 over 2 or 1 and 1 over 5?
1 and 1 over. Oh, it's 1 and 1 over 5. Oh, thank you so much. Thank you.
No problem.
So 1 and 1 over 5. So that's going to be, let's do some corrections here. That's going to be 5 one's 5 and 1 is 6 over 5. Thank you so much. All right. So 5 is 25 and 3 is going to give us 28 over 5 divided by 9 one's 9 plus 5. That's going to give us 14 over 9. All right. Now we've done our conversions. The next thing to do is to square the terms. Now, squaring doesn't mean multiply by 2. I saw quite a few students who actually attempted the paper. Some of them were saying 6 squared is 12. We have to pass that stage now, guys. Whenever you square something, you multiply it by itself. All right. So when you're squaring a fraction, guys, you square the numerator and the denominator. Okay. So that 6 squared is going to give us 36. And 5 squared is going to give us 25. Okay. Minus, we're going to work out what is in this bracket here. So in this bracket here, we're going to be required to do the keep, change, flip. Sure, keep change flip. We know to use keep change flip whenever you're dividing, ladies and gentlemen. Once you're dividing two fractions, you have to keep the first, change the sign, and flip the last. So we're going to keep the first, that's K, change the sign to multiplication, flip the last, that is turn it upside down. All right, keep change flip. So that's going to be 28 over 5, that's how I've kept it. Change it to multiplication and flip the last one, so that's 9 over 14. So we end up with a multiplication to be done. So we're going to again bring down back this 36 over 25 minus the result of this. Now the not LCM, pardon me. Remember, we do not find LCM when we're multiplying, we cancel. So it looks like we could use 2, we could use 14, we can use 14. 14 into itself one time, and 14 into 28 goes 2. If you wanted to use 2, you could have done that, but you'd have to cancel again, right? So it's best to use the highest number. The highest number, the highest common factor to cancel the terms. So in this case, then we end up with 2 times 9 right there. 2 times 9 is 18. And that's going to be all over 5 times 1 is 5. So we end up with a nice fraction like this here. Okay. All right. So therefore, then we're going to go ahead and we are going to say LCM. The LCM here is going to be 25. Because both 25 and 5 can go into 25. Now 25 into 25 will go 1 time. We're going to put that 1 right above the 36. And 5 into 25 goes 2 times. We're going to put that, sorry, 5 into 25 goes 5 times. We're going to put that 5 at the top there. Okay. So we end up with 36 times 1 is going to give us 36. And 18 times 5 will give us 90. If you didn't know that we could get a negative answer for our fraction, it is very, very possible. Not very rare, but very possible. Okay. So yes, our answer turns out to be negative 54 over 25. All right. Now, if you want to leave it there, right? Generally, I would just take off half mark because a fraction that is in an improper form should be converted to a mixed fraction. So in reality, your answer should have been, or should be 2 and 4 over 25, negative. But if you left it as negative 54 over 25, I don't think there's going to be much of a penalty, right? I wouldn't penalize my student for that. But there are some instructors, some markers that, you know, penalize students for not converting back to a mixed fraction. So I don't think it's going to be that big of a deal. But I would recommend that just to put yourself on safe ground. If you get an improper fraction, be sure to convert it back to a mixed fraction as your final answer. Okay. All right. Any questions on that one? Any questions? Nothing? All right. Lovely. Take a screenshot if you need it, guys. If you're not writing with me, take a screenshot. Yes, go ahead. Question.
Yes, sir. I don't understand. I get a negative 2 over 4 over 25.
25 goes into 54 2 times. And that will leave an extra remainder of 4. And it will put it back over 25. That's how you convert from an improper fraction to a mix.
Okay, sir.
All right, lovely. All right. The next question now is a typical CXC problem that comes at question 1. They give you a question that is related to decimal. All right. Now, students, in the future, when you get questions like this that requires or that you're seeing decimal, it's important that you use your calculator. I've seen quite a few students that are actually trying to do long division and all that extra stuff. Don't do all that, guys. That's where you get a calculator, right? You're allowed to use a calculator, so please go ahead and do it. You won't get any extra marks if you show the marker that you can do long division. You're not going to get any extra marks. So go ahead and at least show some type of working. So what I would recommend that you do, right, to show that, okay, I'm not just typing everything into the calculator and getting an answer. You're going to show them that I'm going to work out this part. Then you're going to work out that part. So if we go on our calculator, we're going to see 9.51 times 4.35. Somebody can confirm the answer. I'm going to go on my calculator shortly. 9.51 times 4.35. Give me a sec. All right, so here we go. 9.51 times 4.35, and then you just write down that answer, okay? 41.36, and you can round it up. 41.37, all right? 41.37. So we're going to go ahead and we're going to say 41.37. So we're going to work out that part. We're going to get 41.37. So this part of the problem here is going to be 41.37. So 41.37, rounded off to 1 dp. And we're going to minus now, go on our calculator again, 8.541, 8.541, 8.541 divided by 0.72, divide 11.86. I'm going to keep it there, 11.86. So that's 11.86. So you're showing them some sort of working out. And you subtract those two, 41.37 minus 11.86. Is that 86? Yes, 86. I wrote 89. My apologies. 41.25. Give me a sec. 11.86. All right. So 41.37, 11.86. So 41.37 minus 11.86, right? So this is how you work out decimals, guys. 29.51. So we're going to have 29.51 as our answer. That is exactly. So see, they ask us for the correct answer too. So when you get the correct answer, we just got what? 29.51. Once we get this answer, then we're going to do a bunch of different stuff to it. Okay? So this is what we call our exact answer. This is our exact answer. Okay? Now we're going to round it off to the nearest whole number. So once again, if we go ahead and we take 29.51, the whole number starts or ends at the decimal point. So we draw a vertical line there and check the number that comes after. The number that comes after the 9 is 5, which is basically acting as if it's greater than 5. So we're going to add 1 to 29. Our answer for the nearest whole is going to be 30. Once again, if we take the 29.51 and we round it off to 1 dp, notice that the first decimal place here is 5. So again, we're going to check the number that comes after. This is a 1. So 1 is less than 5. We just pretty much ignore the 1. So our answer is 29.5. All right. You can always review my approximation video or tutorial, right? It's somewhere there on the page. Just look for the title and you'll be okay. And then we're going to go ahead and say 29.51. Well, in this case, they want us to 4 significant figure. When I wrote down this answer, I should have had more decimal places. I should have had more because based on the fact that they're asking for 4 significant figures, I would have needed to know what came after the 5, but I started to round off too fast. So with 4 significant figures, we are already at 4 significant figures. So our answer is going to be exactly what it is there, 29.41. If the number that came after the 1 was, let's say it was a 6 or a 7 or an 8 or the 9, then it would have been 29.52. All right, so just be very mindful when you're getting your exact answer that you don't round it off like I did. I made a big mistake here by rounding off to 41.36 to 41.37. I did too much rounding as I came down. So I should have really written the exact value and then round off the exact value. All right, but nevertheless, I don't think we're going to be penalized too much for that. So those are our 3 answers. All right, so for those who are new and are unfamiliar with the principles of rounding off, you can always check out the tutorial that is available for you on the channel. Okay. All right. That's it. Any questions? Any inquiries? All right. Get used to using your calculators, guys. Okay. Lovely.
There's someone is in the waiting room.
Oh, there's someone there in the waiting room. Okay. All right, lovely. Now, again, a lot of these questions that you're seeing on the screen here, guys, they are not necessarily CSEC-based questions. They are fundamental questions. But, obviously challenging math is with the fundamentals. We've had lengthy discussions on this and how important the fundamentals is. So, again, very rarely are you going to get questions like what is at part C. But if you can't work these questions with confidence, then you can imagine how it's going to be challenging later on. So we want to make sure that we at least are able to work these types of questions, okay? Now, the first question, again, is bringing out the rules of PEMDAS, right? Let's just rewrite the question here. We have 20 minus 2, open bracket, 18 minus 13, oops, small 8, 18 minus 13, plus 100 divided by 50 minus 60. All right. So once again, this is another problem that involves PEMDAS because you're adding, you're subtracting, there are some brackets there is division, there is, it's just a lot of stuff going on. So you have to organize yourself by working out the question according to PEMDAS. If you rewrite the acronym here or the abbreviation PEMDAS, the first thing you can see in PEMDAS is we must work out anything with a parenthesis first. And as you can see right away, there is a parenthesis right here. So I'm going to go ahead and I'm going to say 20 minus 2, right? And parentheses means multiplication. So we're going to squeeze that little multiplication right here, right? Because the parentheses means to multiply. So that's going to be 2 times 18 minus 13 is 5. So that 5 is from the bracket, right? We're going to go ahead and we're going to place this back in a bracket right here because we're not done, okay? I'm going to place that back in a bracket. Plus 100 divided by 50. That's going to give us 2 minus 60. All right, so this 2 is from the 100 divided by 50. Okay, we can go ahead and do that same time. Okay, take out some of the working out. You can do that. You can do it step at a time if you want, but it's just going to make the problem longer. Well, as long as you're allowed to do something, go ahead and do it as long as you're working with the rules. There are no exponents in this question, but there is a multiplication, right? There is a multiplication right here with the parentheses. So that's going to be 20 minus 10 plus 2 minus 60. So the brackets are gone, the division is gone, the multiplication is gone. So therefore, guess what happens? We have addition and subtraction left. So since our subtraction comes before the addition, we can go ahead and subtract here, and we can subtract here. All right, 20 minus 10 is 10. And then we have 2 take away 60 is negative 58. All right, so how you get negative 58? We spoke about the owing and having. So the 2 is positive. We're going to go ahead and assume that that's the amount that you have. The 60 is negative, so that's an amount that you owe. By paying the only 2 that you have, you'd have still been in excess of 58, so that's minus 58. This total answer here becomes negative 48. Okay? So that takes care of that question there. So we need to get into the habit of being able to work out any question that involves more than one operations by using the law of PEMDAS. We have a full tutorial on that. So again, as I said, just make some little jottings on the side during your spare time, your free time. You'll know which video you want to watch, which night to get that in. Okay? So everything is there for you. Next question. So this question was just a bonus question just to ensure that none of my students got a 0. But we have students that will get 0. Very, very likely, right? Because, math requires a lot of discipline. And we all know that many persons don't necessarily have the discipline to do something that they don't really like. So you are going to find that students will get scores that are quite appalling. Nevertheless, here we go. So now this question here was designed to see if you know how to work with your negative signs and positive signs, all right? And the first challenge in this question is where we have some clash of signs. So we have that positive with that negative clashing. We have that negative with that negative there clashing as well. So we're going to rewrite the question without the clashes. So it's going to be -9, -8. Now, when a positive and a negative combine or clashes, as we say, that is in my sign clash video. That's earlier on in the year, sometime in September, we taught this. When a plus clashes with a minus, we end up with a -3, -7. And when a negative clashes with a negative, we all know what that becomes. Positive. +6 +11 -19. Now, I have been observing that there's quite a few persons that have different ways of working out these problems. Some persons will group all the negatives and group all the positives. That's fine. You can do that, right? Because there are some persons who they can't really wrap their mind around this whole concept of owe and have. In my opinion, I think it's a quite easy concept to understand, but everybody learns differently. So some persons, even if you tell them say it's owing means you balance, you owe somebody something. You're not able to see it that way. All right, so here's how I teach it during the class. I tell students to put them into groups of 2. And if there's an odd number out, we just bring it down until it can group itself with something else. Now, -9, -8, we do have many students saying that negative and negative equals positive. That rule only applies when we are multiplying. So negative and another negative will still give you negative. Negative multiplied by negative gives you a positive. So in this case, the -9 is not multiplying the -8. So you cannot get a positive result. You're going to end up with -17. All right, -17, you can always test it on your calculator, verify. -3, -7, that's going to give us -10. 6 + 11, that's going to give us +17. And then -19. All right, put them into groups of 2 once again. The first bracket again is going to be -27 because you owe 17 and you owe 10. So in total, you owe 27. And 17 minus 19, that's going to give us -2. The 17 is the amount that you have. The 19 is the amount that you owe. Pay what you have and you still owe an amount of 2, which gives us a final answer here of -29. All right. You can always feel free to use your calculator if you still have a challenge with the whole concept of owe and have. No one can tell you what to do. What I don't want, though, is for you to just type everything into the calculator and then write down equal to -29. You are only going to get 1 mark from me. All right? Because it's not that your answer is wrong. You just haven't shown me how you got your answer. So since I can't see how you get your answer, I'm just going to keep half of the marks. All right? So that's what we're trying to avoid. We're trying to get you guys to articulate yourself on paper. All right? So that's it for that fundamental part of mathematics. All right? We're going to see many more of these types of questions in the future. Any questions or inquiries, guys? Any questions? Okay, no questions. You can go ahead and just erase this here. Lovely. All right, so we're going to go ahead and we're going to zoom up to some worded problems then. We're going to look at some worded problems. Now, with these worded problems, I think we got up to ratio. I remember the last video that I posted, we got up to ratio. But I'm not sure. Can anybody confirm if I had gone to direct and indirect proportionality? Can you recall? I don't think so because I haven't seen a video on my channel about it. So I don't think I taught direct and indirect proportionality, but these are, and I'm speaking from a general point of view and not a mathematical point of view. These are somewhat kind of common sense questions, but how to work them out is usually the challenge for many students. All right, so we're going to look into these. And remember that these, I taught it?
had, yes, sir. You gave us the steps.
Or I'll give you the
Step
steps.
1, 2, and 3.
Is that ratio or is it proportion?
Examples. Yes, ratios.
Okay, well, yeah, well, this is direct and indirect proportions. I think that's what was supposed to come next. All right, let's get into it then. All right. So can someone read for me? Anyone? Part A. Anyone? Anybody? It doesn't matter. Anybody?
I'm sorry, it's a bit too fine, too small printed for me.
You can zoom up your screen too, you know. I go ahead. Anybody?
A contractor builds a barn in 8 weeks using 5 men. If he had hired 3 more men, how long would it have taken him to build the same barn?
Thank you so much. All right, so let us see if we can reason out the question as opposed to trying to figure out just the solution. The question is saying then, right? And this is why it's common sense, because you are probably going to know what kind of answer you're supposed to get, but you may not know the exact answer. So here's what we're looking at. We're looking at the variables time versus employment, right? So we are contracted to build a barn, right? And in 8 weeks, using 5 men, this barn can be completed. So let us write that down. In 8 weeks, we can build this barn using 5 men, right? The question I'm going to ask you, right? And think before you answer. The question I'm going to ask you is, how long would it take 1 man to build this barn? Would it take more weeks or less weeks? What do you think? Careful now. It takes 8 weeks to build 1 barn with using 5 men working at the same pace. What if you only had 1 person working the barn or trying to build the barn? Would it take a longer time or would it take less time? Let's hear some answers.
It would take a longer time.
A longer time. Now, which of the signs would make things get longer? Multiply or divide?
Multiply.
Very good. So we're going to go ahead and say 1 man. Why did I write 1 man? That's crazy. 1 man is going to take 5 times 8. So 1 man naturally, if this 1 man is working at the same rate as those 4 other men, then it should take him approximately 40 weeks, pardon me, to build this barn, right? Now, continue. Read this part of the question. If he had hired 3 more men, so we're looking at increasing the amount of labor from 5 men, and we're going to hire 3 more men. How many men is working at the moment? 5. How many are now going to be rehired? 3 more. So how much men are we have on staff right now? 8 men. 8 men. So if it takes 1 man to do it in 40 weeks, and we now have 8 men, we can split up these 40 weeks using 8 men. And then it will cut down the amount of time that we have. That's all. So therefore, then it's going to calculate up to then be equal to 5 weeks. Now, I've seen, while I was marking the test papers, I've seen students use many different, even after showing them this way, they find another way to get to the answer. So you're not constricted to just working the question according to how I've done it on screen here. As long as you obey the mathematical rules, then you should get to your answer, right? But you have to also reason it out, because I've seen where students tell me that 1 man will take 5 divided by 8. And when they get the answer, nobody's realizing that there's no way that 1 man can take less time. So we find that the reasoning ability of our students is lacking when it comes to questions like these. When you get an answer, guys, you have to look at the answer and ask yourself, does it make sense? if 8 weeks can build a barn using 5 men, then if I only one person at work, there's no way I can get an answer that's less than 8. That is impossible. So it has to be more. So naturally, then you have to kind of use some common sense and some reasoning and critical thinking in these types of questions, okay? So that's it. That's how you get your 2 marks there. I do have a video on direct and indirect proportion, but it's a video sometime from last year. If you would like for me to send it in the group, I can, right? But I don't necessarily have a fresh 2025 tutorial on it, right? And I don't think I will, because of the time constraint that we have. We may not be able to really go in depth with these questions.
You can go ahead and send it, sir.
All right. Let me see here. All right. Can somebody just write the name? Could somebody just as we're teaching the class, could you just write the names of write the types of the things that I need to do right after the class ends, please? Just write the names of the things. So direct proportion video, approximation video, so that when I'm done, I'll be able to just copy and paste the links and send them in the group. So whoever needs to access them can. So just write them down write down the things that I need to do right after the session. All right, so we take care of that one. Now we're gonna look at this particular question right here. And this is a variation question. Again, you guys never got the chance to get to the actual tutorial on this. So we're gonna have to just touch and go, okay? So this question says that the area A of a square varies directly as the cube of its length. So I'm circling some things that are going to be key to this question. The area of a square varies directly as the cube of its length. The variation is because of the constant k. If the area is equal to 81 and the length is equal to 3, we are to calculate the following down here. Now, before I get into the calculation, let's look at 2 formulas that you may need to recall for doing these types of questions, right? So there is a formula for what is known as direct variation. And that formula is going to be y equals k multiplied by x. Let's put a little box around that. All right, and then we're going to have indirect, or as you will see, inverse variation. That's going to be I don't like that. So we have inverse variation. And so my sincerest apologies, guys. I just got kicked out of the class because of a call coming in. My apologies. Let me go back and share my screen. Are you guys seeing my screen?
Yes, sir.
Thank you. Let's go back here. All right, so for the inverse variation, the formula is going to be y equals k divided by x. So that's really what it is. It's basically a formula that we use to help us to solve these types of questions. Now, very importantly, right? Very importantly, let's see if we can grab a different color ink here to highlight the importance. So very importantly here that in order for you to solve these types of variation, direct and indirect variation, one important value that needs to be obtained, whether you're told to or told not to do it, you must obtain what is called the constant of proportionality. So that's key. So constant of proportion. That is the first value you have to find. You can't solve any question without finding that value. All right? And it doesn't matter if it's direct or indirect variation, you must obtain the value of k. Right? Obtain the value of k. So the constant of proportion. Okay, so you might be asking, sir, how do we calculate this value? How do we get this value of k? Now, before we can even get into the value of k, you need to also understand that many times the question will be structured a bit different. If you notice that in this particular question that you're looking at here, there's no mention of y and x. It says that the area of a square, right, is directly proportional to the cube of its length. So what we have done here is that we have changed the variables from y and x to a and l. So even though the formula is y equals k times x, and because we know that because it says varies directly, so we know that we have to use the y equal kx formula. If you notice here that there's a slight variation in terms of the letters that are being used. So normally it would say y varies direct, so y varies directly as x. Y is always the first letter, and x is always the second letter. No matter what letter they put there, if they want to say d varies directly as t, the first letter is always going to be represented by y, and the second letter is always going to be represented by the letter x. So we have a standard formula, if that makes sense, right? We have a standard formula, but that formula is only used whenever it is that we are talking about y and x. Now, when you get questions from an exam point of view, they're going to use the concept of variation to describe many things. It can be the distance that a car travels as it relates to time. It can be several different things, right? But you have to just remember one thing, that the first letter, right? The first letter right here is always going to represent the letter y, always. And the second letter is always going to represent x. So this first letter here, the area, is going to represent the letter y. And this last letter here, length L, is going to represent the letter x. So we can really adjust the formula a bit here. So instead of saying y equals, we're going to say a equals. And we know that k is never going to change. K is always going to be k. So a equals k times. And now we know that x is being represented by L. Now notice it didn't just say varies directly as the length L, but it says varies directly as the cube of the length L. So that's going to be k times L to the power of 3. All right. I know it's a bit challenging, guys, but work with me. All right. So as opposed to saying y equals k times x, we're going to say a, because a is now representing y, right? See there, right up here. So a, area of a square, is represented by the letter y. So wherever we see y, we're going to put an a, and that's going to be equal to, it says varies directly. That's how we know that we're supposed to use this formula, y equals kx. And it says the cube. So you have to read that part. Sometimes it says the square, sometimes it says the square root, sometimes it says the cube root. In this case, it says the cube of its length. So they're telling us that we should take the letter L and cube it. So that's the formula. A equals k times L cubed. All right? So that's it. So I know it's new, right? And it's a bit rushed, it's a bit fast, because usually whenever I'm teaching this topic, I normally teach it from a fundamental point of view. So I will send the video in the group, right? If it's a challenge for you, you can always take some time out and watch the fundamental breakdown of direct and indirect variation. It will make sense later on, okay? So looking at this formula then, guys, it is going to be A equals K times L cubed. That's what we're going to be using to solve our questions. Now that we have that question then, right? Let's go back to the original then. The original question says now that the area of a square, which we know is now represented by A, varies directly. That's how we know it's supposed to be K times X. Varies directly as the cube of its length. That's how we know that we're supposed to raise L to the power of 3. It says the variation is because of the constant K. That's how we know that K is right here, right? That's how we know all that. It says if the area is 81, so we've been given the first value of A. The area is 81. If the area equals 81, that means you're saying that A is 81. And that's going to be equal to the K we don't know, because that's what we're trying to find. But we are told that the length is 3. So that's going to be 3, and we're going to cube it. Right? Because they're the one that's telling us that, they're telling us that the area is 81 and the length is 3. So they're basically telling us that we should replace the letter A with 81 and replace the letter L with 3. And since L is cubed, then the 3 has to be cubed as well. Okay? All right, so we're at this stage then. Now we have 81 is equal to K, and then we need to work out what is 3 to the power of 3. So I hope we don't have anybody in here who's telling me that this is 9. But we just established that when you raise a number to a power, it means that the number is multiplying itself. So it's going to be K raised to the, or K times 3 times 3 times 3, which is 27. Remember, the dot means to multiply, okay, guys? Just in case you're wondering what does that dot mean, it means to multiply. So K times 27. Now the question then is, how do I get K to be by itself? How do I get K to be by itself? Well, obviously, the relationship between the letter K and the 27 is multiplication, right? That's the relationship. That's what connects them. So to split them, we have to divide. So that's going to be 81 divided by 27. And that's going to give us the value of K. So this will work out that K works out to be equal to 3. All right? So we have obtained the constant of variation, which is 3. Let's put that in a black box right here. Okay? Beautiful. So that's K is equal to 3. Now that we have obtained the value of K, right? That's important because you can't move forward without that value of K. Now that we have K, we can answer the rest of the question here. It says we are to calculate the area. It says we have to calculate the area of the square if the length is 10. So now the length has changed from 3 to 10. So if any one of those variables is affected, or if it's changed, whether it go down or up, something's going to happen to the area. If the length increase, then the area must more than likely increase as well. So how do we solve this question then? Well, we solve this question by once again writing down our formula. And our formula, as we have established, is going to be A equals K times L cubed. Now in this case, now we're looking for A. So sir, why would you be looking for A and they already told us that A is 81? A was 81 when the length was 3, but now the length is 10. So what is going to be the area if the length has increased? Now we already know that K is 3. We've established that K is 3 right here. Times the length is going to be 10 now. So that's 10 cubed. So what do you notice what happens to the area here? It's going to be 3 times 1,000. 10 times 10 times 10. Is that not 30, sir? No. 10 plus 10 plus 10 is 30. 10 times 10 times 10 is 1,000. And so the area then works out to be 3,000 squared meters. Squared meters or centimeters? Squared meters, right? All right, 3,000 squared meters. All right, so it's a tricky question. For some of you, you might catch it. For some of you, you might be struggling, wondering, what is this? You will get that understanding of it. Tutorial. Because it explains everything from basics. Literally how the formula was derived, It gives you a lot of examples of how to work it. So once you watch that video, then everything that is on screen here is going to start making more sense to you. Okay? All right, and that's it for that part of the question here. All right, now the next part then asks us to calculate the length now. So now we're looking for the length now. But this time they gave us an area of 140. So now we're going to write back our formula. A is equal to K times L cubed. All right, now this time the area is 140. So we're going to put 140 underneath the letter A, because obviously that's the only place that it can go, 140. And we already know that 3 is K is 3. And now we're looking for L cubed. We're looking for L. All right, so this time L is unknown. All right, now what is the relationship between the number 3 and L cubed? It's multiplication. So the opposite of multiply is to divide. So that's going to be 140 divided by 3. And that's going to be L cubed. All right, now if we divide 140 by 3, we should get 40 something. 46, 47. Can somebody confirm that for me, please? What is 140 divided by 3? It's 40 something.
47.6, sir.
Thank you so much. 47.6. And that's going to be equal to L cubed. All right. Now in math, in order for us to find anything that has, or well, if something is attached to our variable, we have to use the opposite operation. So just like how you know that adding is the opposite of subtraction, subtraction is the opposite of addition, division is the opposite of multiplication, multiplication is the opposite of division. Now we're going to be learning that cube rooting is the difference, or the opposite, not the difference, but the opposite of cubing. So notice that the L has a cube on it. Let me just grab my calculator here for you. And you see what I'm 7.6. Okay. So let me grab my calculator here for you guys. So cube root now, what we're looking for is this. Look at that. See that button that I've highlighted? You see that button? See if you can find it on your calculator. It should be right above this button right here. So it should be, the writing should be right above it. So look, see if you can find that cube root button. Okay. So I'm going to press that cube root button. There it is. And I'm going to have 47.6. Oh, incorrect. 47.6. So we're looking for the cube root of 47.6. For those who don't know how to get it on the calculator that you may be using, there is a clear the screen for me. Let's clear the screen. And there is a button that's called second function. So, right, see this button here that I have that says 2ND? You should have a button on your calculator that says shift. It's to the top left of your calculator. So if you press the button shift, and then you press the button, this one here, if you press this button that I've highlighted, X to the 3, it should bring up the cube root button. Or some calculators have an actual cube root button, so I'm not sure. Depends on your calculator. So try any one of those strategies. Equal, my answer is 3.62. All right, so 3.62 or 3.6. So the answer here is 3.6.
So I get 3.598.
Round it off. How much you get? 3.6 when you round it off.
Okay.
So you end up then with an answer that's equal to. So L is equal to the cube root of 47.6. That's equal to 3.6 rounded off meters. Okay. So yeah, tough question, right? Especially if it's new and you haven't never learned it before, it's going to be challenging. But that's why we do math, because it has a challenge. So it has a challenge. All right. So that is it for that question. I'm sure you may have a bunch of different questions later on. But if you look here, we have another one that's coming. So hopefully you'll be able to replicate what we just did here. We have another one coming shortly. All right. All right. So that's it.
Not seeing a screen, sir.
Pardon me?
We're
You're not
not
seeing my
seeing a
screen?
screen.
Okay. Okay. Thank you so much. All right. So you should be seeing it now. Confirm?
Yes, sir.
Lovely. All right. So let's not dwell on it too much. With time, it's gonna get better. Okay. And we understand why we're at the position that we're at. All right. So I'm gonna quickly just erase all of this. Right. Hopefully you guys can recall what it is when we get back to another variation question. All right. So we have another question here. It says that whoops. Oh Lord. Zoom out too much. All right. Here we go. So for part C then, 2C. So we have a train can travel approximately 252 kilometers in 42 hours. It says, given that the speed of the train remains the same, approximately what amount of time will it take to complete a journey of 354? Again, this is a common sense question that doesn't require critical thinking. To get the correct answer, you need some math. But to actually figure out if it should be higher or lower, you can common sense it out. All right, let's think about it now, guys. If you're traveling this amount of distance in this amount of time, what happens if you need to go a longer distance? Is it going to take a shorter time or less time? Less time or more time? That was a question now, guys. So if you're traveling 252 kilometers in 42 hours, and you're now required to travel a longer distance, the question is it going to take more time or less time?
More time.
More
More
time.
time, sir.
So that means you're expecting then that after the calculation, whatever calculation you put down, your answer should be greater than 42, not true? That's the first critical thinking that I want you guys to do when you get these questions. Think about what your answer should be. That means if you're doing the calculation, you get an answer like 40, you know, say something wrong, or 35, or 30, or 20. You know something wrong because common sense is telling you that you should what? Get a higher number than 42. Because I'm going a longer distance, so naturally it has to take me a longer time. All right. Now let's set it up. To work out these questions, usually you have to start off by writing down what you know. So what we know for sure based on this question is that this train, all right, whether it's true or not, they're telling us that it takes a train 252 kilometers to travel a distance. Sorry, it takes a train 42 hours to travel a distance of 252 kilometers. So 42 hours can carry a train for 252 kilometers. So we're not looking into whether it's true or not. We're working with whatever was given to us, whatever variable. So we know that in 42 hours, a train, that's it. That train can travel 252 kilometers, right? Our task then, the first task for you as a student to do is to calculate how long would it take the train or how far can the train travel for only 1 hour. So the question then is, will it travel a shorter distance or a longer distance in 1 hour? 42 hours can carry 252. What if it was only traveling for an hour? Would the distance be shorter or longer?
Shorter.
Shorter. So therefore, which operation make things shorter? Multiply or divide?
Divide.
Naturally. So that's 252 divided by 42. So run that on the calculator for me. How much you got?
6.
6 hours, 6 kilometers. So in 1 hour, this train is traveling really slow, man. Really slow, barely a move. In 1 hour, this train will be able to travel 6 kilometers. Now, how far are we trying to travel? 354. Not true. And in 1 hour, it will travel 6. Therefore, I need to find out how many 6 kilometers can I get out of this 354. So I want to travel a distance of 354, and I know that 6 kilometers will take me 1 hour. So I need to find out how many 6 kilometers can I get from 354. That will tell me the amount of hours I need to travel. Talk to me. How much you got?
Sir, 59.
Very good, 59 hours. And it makes sense. Because we don't establish from day one that our final answer has to be greater than 42. Because I'm traveling a longer distance, it should take me a longer. So if you notice that the common denominator of these questions, guys, is the ability for you to recognize that you need to always find the value of one share. So once they give you the information, you write it down. Whatever information they give you, you write it down in any order. And then you go ahead and try to find the value of one share, 1 hour. That's what we did in the last question. We found out how long did it take one man to build the barn. And one man took 40 weeks to build the barn. So we did some calculation there. So again, you will see all of this being highlighted in the tutorial video. Chance to watch it. Okay. So that takes care of that question there. Lovely. All right. Moving right along to the next one here. All right, so what we're looking at then is this. All right, so we're looking at another variation, but this time, guess what happens? It varies inversely. Let's recall what the formulas for direct and indirect variations are. The direct, we had written it down earlier, but we erased it. So let's rewrite it again. Direct variation. Let's just write this a little better. Okay, direct variation. It's going to be y equals k times x. And with inverse variation, it is going to be y equals k divided by x. And remember, we also stated that the important value in starting this question is to find the constant of variation. So sometimes they'll tell you to find it, sometimes they won't. Regardless if them tell you or not, you know that this is a mandatory value to be calculated. Let's read the question. Once again, it's going to change it up again. They said here that the distance d varies inversely as the square of the time t. So what letters are we using? We know that the standardized formula is y equals kx. But what did we discuss in our last section? We said that the first letter is representing y and the second letter is representing x. So we can restructure the formula. The distance d is the letter representing y. So we can put d right here. And we know that k always remains. Now, is it direct or is it indirect? Let us find out. It says it varies inversely. So we know that the formula that we're going to be using here is y equals k over x. So d equals k divided by, what letter is representing x now? We know that the letter representing x is t, but it does says square of the time. So we're going to square the t. So we end up with that formula there. D equals k over t squared. Okay? So majority of the time, guys, your formula, the general formula y equals k over x, will have some adjustments to it. Slight adjustments, right? So you have to read the question and then you can verify, right? And this you can only understand the concept once it is that you're working these questions consistently. Like you don't need a whole lot of these questions. You just need maybe like a couple. Just maybe like a couple. Maybe like about 5 of them and you'll get the hang of it. All right? So d is equal to k over t squared. Remember, the first letter in any question represents the letter y, and the second letter will always represent the letter x. The variation or the changes usually occur on the letter x. So you have to look to see if it says the square of x, the cube of x, the cube root of x, the square root of x. What exactly happens to x? Sometimes nothing happens to it. All right? So it depends. So we're looking at d equals k over t squared. Write that up here. D equals k over t squared. All right, lovely. Let's get into it then. Now it says we should write an equation in terms of D and T and K. Wow, so we have it there. So we have an equation in D, K, and T. Lovely. So write an equation in terms of dt and k, and dt and a constant k, and show that the variation above is relation, and show the above variation, which we have done. D equals k over t squared. It says that we should go ahead and state the value of the constant of variation. So like I was telling you earlier, ladies and gentlemen, in some questions they will tell you to calculate k, while some questions like the one before, they not mention nothing to you about calculate k. Regardless if them tell you to or not to, you know that you must calculate the value of k. So sir, how do we do this? We do this by using the two values that they initially give us. And if you notice that they said that what? We should determine the value of d and t is equal to 5. So hold on, before that, they gave us something before that. They said that t is 2 and d is 25. So see that? They said, given that d is 25, so we're going to put 25 here. And we know that k is unknown at the moment. And they said t is 2. So we're going to put 2 squared right here. All right? So t is 2 and t is squared, so 2 has to be squared. So it's going to be 25 equals k over 4. Now the question then is, what is the relationship that k and 4 have? What connects them? What sign connects them? It's very evident that it's not a multiplication, but it is in fact a division. So what's the opposite of dividing? It's going to be multiply. So in this case, then k will be equal to 25 times 4. So k works out to be 100. So that's the value of k right here. All right, 25 times 4. All right, good. So now that we have k, which is key, we can then move on to this question. Remember, these questions down here, this one and this one, you cannot find anything down there that you're talking about until you get k. K is where it's at. You find k, you're halfway through the problem. Let's go ahead and rewrite the formula. D is equal to k divided by t squared. Let's start up. It says that we should determine.
Someone got kicked out.
Are they in the waiting room?
Yes, sir.
They are. But a few persons. All right, so D is equal to K divided by T squared, right? Now we are now required to determine the value of, give me a second, let me just click here. So we are now determining the value of D. So read it, determine the value of D. That means D is unknown, but this time it's, if T is 5. So D is unknown, and we just calculated K to be 100. So we're gonna put 100 here. And we are now being told that T is 5. So since T is squared, 5 is going to be squared. D is equal to 100 divided by 25, which we just learned here that this is equal to 4. Okay, so D is now equal to 4. So that's how you work out that question. So you can see the key here in this question is getting K. If you get K, you're good to go. All right. And again, we're going to move on to the last one here. Yeah, question. Okay. Determine the value of T. So now T is unknown. First one was determine the value of what? D. Now the second one is determine the value of what? T. So determine the value of T, but this time when D is 40. Remember I said D was 25 up here now. So what happens now when D is 40? Again, formula is D equals K over T squared. D is now 40, so we're going to put the 40 right underneath the letter D. That's going to be equal to K, we already know is 100, and that's going to be over T squared. All right. Now we're going to do a little thing. We're going to do a little shortcut here, right? And as time goes by, you'll understand what I've just done. I'm going to swap positions. So I'm going to put the T squared up here. I'm going to put the 40 down there. You're allowed to do that. It's legal, mathematically legal. If you do it the long way, you'll realize that the result that I'm going to get is exactly the same. So what we do is that I normally tell my students that when the unknown variable is at the bottom of the fraction, we can do a swap. Right? We can swap the position. So I'm going to swap the position with the 40 and the t squared. I'm going to go ahead and say, I'm going to go ahead then and say t squared, pardon me. I'm going to say t squared is equal to 100 divided by 40. All right. So you can go ahead then and say t squared is equal to, you can leave it as a fraction if you want to. I would leave it as 5/2. You can reduce it if you want to. Go ahead, guys, and tell me if 100 divided by 40 is 2.5. Confirm it, please.
Yes, sir.
All right, so if you want to put it as a fraction, 5/2, or you want to put it as a decimal, it's up to you. Now, how do we calculate t? Remember, we said that earlier, that the opposite of cubing is cube rooting. Now we're going to learn that the opposite of square is square rooting. So t is going to be equal to the square root of 2.5. And you'll find out that t works out to be 0.5. What's the square root of 2.5?
I get 1.5, sir.
All right, my bad, 1.5. All right, so the square root of 2.5 is 1.5. Are you sure? Double check that again, please. That key is off.
No,
1.58, sir. 1.58. 1.6.
Yeah, 1.6. Yeah, when it's squared.
That one that kind of sound shaky a while ago, 1.6, right? So that's our answer, 1.6. Okay. All right. So that's variation. Again, I can relate. I know that for some of you guys who are seeing this for the first time, these questions are questions that comes on exams regularly. Regularly you see them, right? Very often they come. All right. So that's what's going to be the learning process for the next 3 weeks of school, next 3 to 4 weeks, guys. It's going to be a crash course, more crash course than ever. So you have to grab and go, grab and go. I will not give you I don't know if you guys want to do an end of term exam. I don't know if you want to entertain anybody. It's good to test yourself to see where you're at. Right? But I don't mind cutting out the end of term exam for you and just teach you. So we can make a vote. I can send a poll in the group, and then you guys can decide if you want to take on an end of term exam or you just want to just use the time and just teach. All right, so that takes care of that question. We're going to move right on into, and feel free to watch back the tutorial, right? If it's even to fast forward it up to this section and just watch what was discussed, you have the option of doing that as well. Okay, moving on. Ratio.
Excuse me, sir.
Go ahead. Question.
Will this be posted on YouTube also?
Oh yeah, man. Everything is posted there.
Okay, thank you.
And I'm going to post it tonight, in fact. All
okay,
right.
sir.
Yeah. So,
Hi, sir. So I got kicked out when you were writing down the formulas for the variation. Is it possible to just let me see that quickly, please?
As in from the very first beginning?
Just the formula that you were writing down for direct variation and inverse.
Let me see if I can undo all the way to that part. I don't know.
That's where I got kicked out, so I just would want to write that down.
Oh, I can just write. Let me just rewrite it back for you. Hold on, give me a sec.
Okay, thank you.
Oh Lord, I made a mess of my screen. Okay. So the formula for direct variation, here it is. So direct variation is y equals k times x. And then for inverse variation, it is y equals k over x.
Thank you.
You're welcome. All right. We're almost done, guys. Just 19 more minutes. You're so fast, 2 hours now. Plus, I still owe you 15 minutes. I forget. Gonna start late. All right, so let's move on to this part of the question here. So, 3 cousins, Adam, George, and Christy, were given a sum of money to be shared in the ratio 5 to 8 to 3. Christy receives $700 less than Adam. We are to calculate the sum of money that was shared among the cousins. Part 2, we are to express George's share as a percentage of the total sum, and we are also to state the amount that Adam received. All right. So, majority of you, I think, would have either is either you were in the class when I was teaching ratio, or you perhaps clicked on it and you were watching it. Right? The last month or so, I don't think anybody was in the state of mind to really go and watch a YouTube video on math. You know, we were all picking up the pieces. So I can understand if you guys never get a chance to watch it. But my recent video, the most recent video, not recent, because I've just posted one a while ago. The one before that, it says ratio proportion. You can always check it out. There's a full tutorial on that, the whole breakdown on ratio. So if we can recall that the step number 1 when working out any question is to write down the comparative quantities. So the comparative quantities are the persons involved in the ratio. That's going to be Adam. We're going to write there. We're going to use the initials of their names. We're going to compare Adam, that's A. And we're going to compare Adam to George, that's G. And we're going to compare George to then Christy, that's C. So the ratio, the comparative quantities in the ratio is Adam to George to Christy. So we're going to use A. We're going to use A to G to C. And the ratio between them is going to be 5 to 8 to 3. All right, so that's the ratio. So I always encourage students to do this. Write down what the comparative quantities are and what are the individual ratios. Step number 2 is to find what is called the TP. The TP. TP stands for total proportion. To find the total proportion, we're going to add those numbers, 5 plus 8 plus 3. Now, a lot of questions may not require the total proportion, but I just find it anyways, and just in case I need it, I'll be able to access it. So in this case, 5 plus 8 plus 3, that's going to give us a total here of 16, my bad. Where did I get 15 from? 16. All right, so that's the total proportion. Now, here's the tricky bit. All right, here's the tricky bit. The tricky bit in this question is that many persons, when they read it at first, they will assume that $750 is what is being shared. All right, when you read it the first time, that's the first thought that's going to come to your mind. When you read it the second time, you'll then realize that there is something funny about the question. And then when you read it the third time, you'll then realize that it's not the $750 is being shared, but it means that somebody got $750 less than someone else. So be very mindful, because it's very easy to interpret the question to think that it says Christy received $750. No, read it good enough. It didn't say Christy received $750 alone, It said Christy received $750 less than somebody, which is Adam. So the question then begs, how is this possible? How them know that? How did Christy receive $750 less than Adam? If you notice that Christy got what? 3 shares, and Adam got what? 5. So therefore, it's very evident why Christy got less money than Adam, because Christy got 3 shares and Adam got 5. So we can write down that the difference between the shares is 5 minus 3. That's 2. So therefore, you see that number 2 there, that 2 shares, that's exactly the reason why Christy got less money than Adam. So that 2 shares that Adam got over Christy is the exact reason why Christy got less money than Adam, right? Because Adam got 2 extra shares. So that 2 shares is equal to 750. We can therefore, once again, as I've been telling you earlier before, always find the value of 1. 750 divided by 2. That's going to give us $375. right? And there are some other ways that I've seen on AI and seen other teachers. Everybody has a different way of approaching the question. To me, I just try to show my students. I just try to show myself. I'm not going to say the easiest way. I'm just going to say, to me, it's the more obvious way. The way that will take out a lot of the complexity. So one share is going to be 375. Therefore, what did the question say? That we should calculate the what? Sum that was shared among the cousins. So among everybody. So we know right away that 16 shares is equal to everybody. Because Adam got 5, George got 8, and Christy got 3. So together, all of them got 16 shares together. And we know that one share is 375. Therefore, 16 shares is going to be equal to 16 times 375. Can somebody confirm what that answer is, please?
$6,000.
$6,000. So $6,000 was split. All right. Please watch if I know it's a lot of videos to watch, so that's why you can't watch it in rush. Sometimes some of these videos are so long you can't even watch them one time. So you have to watch them like half an hour, then you watch 40 minutes, stuff like that. So watch them in bits and pieces, guys, right? So you don't make sure you don't get lost in the explanation. But in the class before, as you know what happened over the past month, it was we had a breakdown video of this with basic questions. So check it out, and you guys, this should make a lot more sense to you then. Okay, so 6,000. All right. So the last one here is going to be that we should state the amount received. Sorry, we should express George's share as a percentage of the total sum. That's quite straightforward. George got what? Sorry, pardon me. Whoops. George got 8 shares out of the 16. So George would have gotten 8 shares out of the 16. As a percentage, it's going to be times 100. So it's natural to say that George would have gotten 50% of the money. So George got half of the 6,000. Right? Because George got 8 out of the 16. Therefore, George would have gotten half of what is there. It's 50%. All right. And then now we should state the amount that Adam received. We should state the amount that Adam received. Well, that's very straightforward again, because we know that based on the ratio, Adam would have gotten what? 5. And we know that what? One share is 375. One share is 375. So therefore, it's safe to say that Adam would have gotten 5 times 375. And I believe that it's going to be 1,000. No, sir, not 1,000, 2,000 something. Can somebody confirm 2,100 something? Can somebody confirm that? No, is it 1,800 and something?
1,875.
1,875. Thank you so much. So that means Adam would have gotten $1,875 from the money. Okay. So that is it. That is how you work out that. So that is the fundamental part of the video. Of this worksheet. Again, I will be doing a full breakdown of this. This that you're seeing on the screen here, ladies and gentlemen, is just for you. Just for you, right? This is like a class. But on an actual tutorial, I will be working out these videos and I will be posting them, as if I'm talking to the whole YouTube world. I'm going to have a video on the paper, exactly, because evidently when you look at it, there are some questions there that you have not yet been taught, like coordinate geometry, right? You haven't been taught algebra as yet, which is a topic that we're actually going to go on during the course of this week. So you are going to be seeing some algebra this week, ladies and gentlemen. So fret not thyself. All right. So so as you can see here at the bottom, there are some algebra which you need to learn, right? Coordinate geometry. I'm not sure if you guys are going to be doing that this term, but you will be doing it at the beginning of next term, next semester. And then you also have, right, that's the end of it. So down here, so it's another paper now. This is a different paper. I don't know if you guys want to go ahead and take a screenshot of this one, right? This was the one given to the day school. So you can go ahead and take a screenshot of this and you can try it. You can try some of the questions that are here, right? So that when I eventually get there, you'll be able to, right? Hopefully you guys took a screenshot. Scrolling up. Here's another one. There are some consumer arithmetic questions as well. So you can look through them. You can try them. If you can't do them, it's okay. That's what I'm here for. So we're going to look through some of these. All right. That's a screenshot again. And there's some other ones on here. Here are some algebra questions as well. All right. Now, we may not be able to catch up with everything, but we are going to get
Sir,
somewhere.
can you go back?
Yeah.
Sir, can you please go back to the other one? I was trying to zoom, but when I zoom, I'm not
Sir.
getting all of it.
Yeah, go ahead. For the first one you're talking about, here's the first one. That's the first one. Yeah, somebody said sir a while ago. Go ahead.
Sorry, is it possible? If you could maybe send it in the WhatsApp group, because I did a screenshot, but it is somewhat very
Oh, it's uploaded in the Google Classroom, you know. It's already there.
Okay, sir.
Yeah, man. I think it's already, if it's not there, then I'm gonna go ahead. I'm gonna go ahead and check to see if it's there. And if it's not, I will upload it for you.
Yes, sir, that would be best. Because it's
Yeah, man, no problem.
picture taking is not working.
Yeah, the Zoom thing now work. All right, no problem. All right. So then, the only thing that I would have wanted to do, and like, remember, whenever I post this video, please use it as your form of practicing, right? Because whenever I do my videos, for anybody who has ever watched a full tutorial, I don't just teach you how to work the questions. I teach you multiple ways of approaching the question. So when this video is posted, you see assessment number 2 or assessment number 1. Use it as your way of studying. Let's say that you don't have the time to study during the week because of family, kids, this, that, and the third, and a whole bunch of stuff. These videos are usually like an hour and a half long or 2 hours long. So, I mean, if you study for 2 hours a week, that's good, right? And you're not just studying, you're learning multiple different things that has not been taught you fundamentally, but they're being explained to you from a fundamental point of view. So I want you guys to take the time out and watch these so that whenever it is that I'm teaching this topic, you'll be better advanced, more comfortable in learning them. Okay? So please make sure you tune in for that one. All right. So that would be it for this session. Right? We are 3:54, although we start late. I don't want to. Let me see if there's something else here that I can do. Let's try this one. Number 5, because we have some time left. I won't be able to do part B because I don't think I have the diagram. I don't think I have the diagram for this, do I? I don't think I have. Let me see if I have the diagram. I don't think I have the diagram, guys. No, I do not have the diagram. Give me a sec. Hold on. Woo. Let me see if I have the diagram. I don't think I do. Oh, gosh. I don't think I have the diagram, guys. But I'll be able to work part A for you, though. I'll be able to work part A, but I won't be able to work part B because part B requires a particular diagram, which I did not have on the screen. I don't have access to it right now. So let's just run through part A, and then let's get out of here, okay? Let's get out of here. All right, let's go. So this was a topic that was actually being taught, right? We were on the topic of measurement. So let's go. 2 flowers garden. Does that sound right? 2 flowers garden. Yeah, right. That's correct. 2 flowers garden that are in the shape of a square and a rectangle, respectively, have the same perimeter. In fact, as I read, let me just highlight some things that I know are going to be important. So 2 flowers garden are in the shape of a square and a rectangle. So we know that we need to draw those, respectively, right? So 2 flowers garden. And they both have the same perimeter. We are familiar with what perimeter means. Perimeter means the distance around the edge of the shape. Now it says that if the area of the square is 170, so we're getting some information now. We know something about the square. and the length of one edge of the rectangle is 19.7. Use this information to calculate the following: the perimeter and the area. All right. So, ladies and gentlemen, typical worded questions. These are typical, general, expected questions on exam. They usually come at question number 3. All right. So, 2 flowers garden are in the shape of a square and a rectangle, respectively. Let's draw them. All right. Let's draw these flowers garden. All right. Let's grab this one here. All right. So here's my flowers garden. This is my first flowers garden. I don't like how that look. That look good, guys? I don't like how that look. How it look? It look good?
Sir, that looked like the rectangle.
Oh. All right, let me try it a bit. How me look? Me all right now? How me look now? One look like one square, one look like one rectangle. Not true?
Yes, sir. Good.
All right. Me look all right. Me look all right. Me looking nice. Lovely. Boom. All right. So what are they saying now? So 2 flowers garden are in the shape of a square. So this is flowers garden A, and this is flowers garden B. All right. Good. Now, what information do we know? We know that they have the same perimeter. So what does that mean, guys? It means that the distance around this is the same as the distance around this. Not true? Do we agree? Based on information given, is our interpretation right? Around the edge of the shape, when I add up, let me put on some letters. So for my rectangle, for my square, I'm going to say that this side is L, this side is L as well, this side is L, and this side is L. Not true? And for my rectangle then, I'm going to call one side L, I'm going to call the other side W, length and width. So this is going to be L, this is going to be W, this is going to be L, and this is going to be W. Not true? Everybody in agreement?
Yes, sir.
All right, good. Now, so we know that they have the same perimeter. So we know that when I add up these 4L, when I add up this L plus this L plus this L plus this L, it's going to give us the same measurement as when we add up this L plus this W plus this L plus this W. We're going to get the same answers, right? That we know for sure. Let's continue. It says if the area of the square is 170, so now we get some extra information now. We know that inside here measures 170. So if we know that in there measures 170, how do I calculate the length of the square? Can anybody give me an idea? What would you do? If I know that the area of the square is 170, I can use that information to find the length of one side. Can anybody tell me what I would do, or how would you approach this? Think about it, guys. What's the area of a square? So we discussed this, We'll go through this step by step, So check the notes, guys. Check the notes for me. What is the area of a square? What's the formula?
Is length times width, sir?
That would be the area of a rectangle. Give me a better one. You're not wrong, but technically, so technically that's not what we say. The area of a square is something. Length times width. Let me just write it over here, because I know you feel like you're wrong. So area of the rectangle, we know is length times width. We know that. But there's a formula that we use for the area of a square. Can somebody remind me? Are my students letting me down? Have we not seen L squared before? Are you not familiar with A equals L squared? Sure you are. So that means that we need to revisit a video did. All right, so the area of a square is L squared. All right. Now, if the area of the square is L squared, what number do I put under the letter A? Look at the screen, guys.
170. 170.
Put 170 right underneath the letter A. Why we put it there? Because them tell us that the area is 170. And that's going to be equal then to L squared. So how do I get L then? Since L has a square, how do I get L?
Divide, sir.
Divide by what? There's no number in front of the L, so we're not going to divide. What's the opposite of squaring?
Square root.
Very good. So we're going to go ahead and we're going to say L is equal to the square root of 170. Go ahead and tell me what that is, guys. What's the square root of 170? Come guys, work with me now. What is the square root of 170?
Sir, my background noise, 13.03. That's what I'm getting.
Somebody can confirm that? We can confirm it. Square root of 170.
Yes, sir.
So clear this. So square root of 170. So she's getting 13.03. All right, so 13.04, 13. I would just write 13.03. So therefore, what are we saying then? We are saying that we can remove this L from here then, because now we know what it is. So basically then, because of the information given to us about the square, we did a little calculation and we found out that this side is 13.03. So obviously all the sides, because remember that with a square, all the sides are equal. So this is equal to that, equal to that, equal to that. Not true? Good. All right, so how would I then find the perimeter? Remember now, both of them have the same perimeter, So if I know that one side of the square is 13.03, how can I calculate the perimeter?
By adding all of the sides.
All right, so that would be what? 13.03 4 times?
Yes, sir.
What's the shortest way to write that down?
13.03 times 4.
Excellent. 13.03 times 4. What would that answer be?
Sir, I'm getting 52.12.
Can somebody confirm that, please?
Correct.
52.12 centimeter. All right, lovely. So now we know that the perimeter of the green square is 52.12. And since that's them say right up here, so say they have the same perimeter, we can logically deduce that the perimeter of this rectangle is also 52.12. So going around the edge here, so around the edge here, let me just grab my black ink. Around the edge here is going to be, so around this edge here, coming around here, this one, that measures what? 52.12. Based on the information given to us. They told us up here. See, them tell us right up here, so that the square respectively have the same perimeter. They told us that. So that's how when we found the perimeter of the square, we deduced that the perimeter of the rectangle is also 52.12. Now continue. It says that the area of the square is 170. We got that part. It says the length of one edge of the rectangle is 19.7. So the length is 19.17. So we can erase this part here. So, and we can put what? 19.17. 17? No, 19.7. So what do we know about a rectangle? If this is 19.7, is it safe to say that down here so it's also 19.7 as well? Can we say that?
Yes, sir.
We can say that, not sure.
Yes,
because
sir.
the opposite sides of a rectangle are equal, right?
Yes, sir.
So how then, based on reasoning then, we know that the perimeter of the rectangle is 52.12. And we know that 2 of the length is 19.7 each. How do we then calculate the two sides? The two edges, the other two edges. What would you do? What mathematics would you do? Think about it now, you know. We have this, you know. Remember saying, you know, this, and whatever this is and whatever that is adds up to 52.12. We know that for sure, because perimeter means distance around. So since as we know this and we know this, what can we do to find the length of those other two edges? Let me hear you guys.
Add the two that you have.
Right.
Take away it from the 52.12.
Yes. So here you're gonna tell me what to write down. Because I don't know what to. So go, you're correct. So tell me what to write down. What do I write down on paper? How do I articulate myself? I'm not hearing you. If you're talking, I'm not hearing you.
What it would be 19.7 length times 19.7 minus
19.7 times 19.7 or 19.7 times times 2.
2, right? Minus from 52.12.
So hold on, give me the answer for this first. 19.7 times 2, how much is that?
39.4.
39.4. Somebody confirm that, please.
Somebody confirm, yeah.
I think you're right. All right, and then you say take it away from 52?
Yes, sir.
All right, good. So go ahead and take it away then.
12.72.
How much?
12.72, sorry. And then you divide it into 2.
Very good. That's what I was about to ask. Are we done? No, we're going to divide it into 2 because the 12.72 is when you add up both of them, but I want them individually. So what would be the answer if I divide it individually?
6.36.
6.36, which is about 6.4 centimeter. All right, so lots of critical thinking comes into questions like these, ladies and gentlemen. Lots of critical thinking. So it says that the perimeter of the square of the floors, we did that part. And it says the area of the rectangular garden. So how would you find the area of the garden then? How would you find the area of the rectangular garden? Remember, I said this is now 6.4 now. Rounded off. So how would you find the area of the rectangular garden? What's the area of the rectangle? I think Miss Stacey said it earlier. When she was asked what's the area of the square, you gave me the wrong formula. Was it length times width?
Yes, sir.
All right, good. So what's the length? 19.7 as they gave us. And the width is now what we calculated to be 6.4. So what's the area?
126.8.
126.8?
Yes, sir.
Very good. Squared meters. Squared meters or squared centimeters? Squared meters. All right. All right. So that is it. Tricky question. But like I said, whenever I do the video on it, you'll have much neater diagrams drawn, much more explanation, step-by-step guidance. So keep an eye out for it. All right. So that is the end of it for today's session based on the topics that you were taught before the hurricane. Right. So once I complete the video, you will be notified, and just stay tuned. That's all I can say. Stay tuned. So I'll see you guys tomorrow again at 7 p.m. Remember, login time is 6:45. I'll try to get home by that time, but we'll definitely start at 7 p.m. and we're going to dive into the topic of consumer arithmetic. Okay? We're going to be looking at some worded questions tomorrow. Yes, talk to me. Question?
No, sir.
Oh, no question. Okay. All right. So that is it. Anything else to say, guys? Any questions? All is good? All is good. All right. Well, if that's it, have yourself a productive, safe, and prosperous rest of day and a prosperous rest of week. See you guys tomorrow at 7. Until then, take care. Bye-bye.
Yes, sir.
Thank you.
Bye. So I'm going to have I don't have any light same way, sir.
Oh, so you have got the pen on the recording.
Yes, sir. I'm going to use data, but you know how the data is.
Yeah, I understand.
Yes.
All right, take care. Bye.
Bye. Bye.